In this video, we will practice dividing complex numbers. And really, when we divide complex numbers, we have one goal. We want to get rid of any I that is in the denominator. We want no i's in the denominator. Now, there are two types of problems. Problems that have a monomial in the denominator and problems that have a binomial in the denominator. When you have a monomial like these, it's very simple. All you have to do is multiply the numerator and the denominator by I. Now this is legal because you're multiplying by something divided by itself. So I divided by I is going to be 1, so we're not really changing anything. Alright, so what happens? If I multiply the numerator by I, I'm going to get so I'm just doing the distributive property. So I'm going to get I plus 4I squared. In the denominator, I'm going to get 5I squared. Now, remember that I squared is negative 1. So that's going to give me, okay, so this 4I squared is 4 times negative 1, so that's going to be negative 4. Okay, and then I still have the I. I'm just putting it second because you always put the imaginary term second. In the denominator, we have 5 times negative 1, so that is simply negative 5. So this is one acceptable version of the answer. There are a few others. Let's take a look at number 6. Okay, again, since this is a monomial, all I have to do is multiply by I over I. So I'm going to do the distributive property here in the numerator, just like I did before. So that's going to give me 4I minus 6I squared, and down here I'm going to get negative 2I squared. Now remembering that I squared is negative 1, then I'm going to have, that's going to turn this minus 6I into a positive 6. Alright, negative 6 times negative 1 is positive 6, and I'll go ahead and put the 4I second because you always put the imaginary term last. Now negative 2 times negative 1 is positive 2. Now on this problem I'm going to go one step further. See how all three of these numbers are divisible by 2? When you have a common factor like that, then you should go ahead and do it. So I'm going to take all three of these numbers, which fits nicely inside this heart, and I will divide all three of them by 2. So that will simplify and give me 3 plus 2I. Well, I started to say over 1, but that would be silly. We don't write a 1 in the denominator. So our final answer will simply be 3 plus 2I. Looking at number 7, once again, let's go ahead and multiply by I over I, since we have this monomial in the denominator. And we will do the distributive property here in the numerator. So that will give us 4I plus 4I squared. In the denominator, we get negative 6I squared. Now remembering that I squared is negative 1, then what we have in the numerator, 4 times negative 1 is negative 4, which I put in the front. Then I will bring down the 4I because the imaginary term goes last. Negative 6 times negative 1 is positive 6. Now notice that all three of these numbers are divisible by 2. So that is a common factor. So when you have a common factor, you need to go ahead and divide all three numbers by the common factor, the greatest common factor, the GCF. So that's going to give me negative 2 plus 2I over 3. So this would be an acceptable answer for number 7. All right, there are a few others. Okay, number 8. One more time, we will multiply by I over I. All right, which is what you do when you have a monomial in the denominator. So I will distribute this I, and I will get negative 5I minus 5I squared. In the denominator, I will have 4I squared. Now, I squared, as you know, is negative 1. So that's going to give me, in the numerator, negative 5 times negative 1 is positive 5. So I'm going to have positive 5 now. All right, then I will bring down my minus 5I. You always put the imaginary term second. Now, up here we have 4 times negative 1. So that's going to be negative 4. Okay, so there is no common factor. So this is one acceptable form of the answer. Alright, things get a little bit more interesting when you have a binomial in the denominator. So first of all, before I do anything else, this negative sign out front, I'm going to go ahead and put that negative sign up on the 6i. So this will become negative 6i instead. Now, when you have a binomial, what you want to do is multiply by the conjugate. So the conjugate is where you just change the second sign. So I'm going to keep the positive 1, but instead of minus 5i, I'm going to put plus 5i. So we're only changing the sign on the imaginary term. Now, we have to multiply by the same thing in the numerator. So I'm going to multiply by 1 plus 5i over 1 plus 5i. Okay, now in the numerator, all I have to do is distribute the negative 6i. So this is going to become negative 6i minus 30i squared. Okay, now down here I need to double distribute. So I need to distribute this 1. So that's going to give me, let's see, 1 times 1 is 1, 1 times 5i is 5i. But then I need to distribute the 5i. So now I'm doing this. Okay, and that's going to give me negative 5i minus 25i squared. Okay, now remember that I squared is negative 1. So because of that, this negative 30 is going to change to a positive 30. So I'm going to wind up with negative 6i plus 30. Alright, because I squared is negative 1. So this is negative 30 times negative 1 is positive 30. Now I might as well go ahead and cancel these out now. They are gone. So I have 1. I'll bring that down. And then this minus 25i squared will become a plus 25. Again, I squared is negative 1. So this is negative 25 times negative 1, that is positive 25. So bringing my calculations up, I'm going to switch these around and write 30 minus 6i, because you always put the imaginary term last. And this is going to be over 26. So I'm just adding these up. Notice we have no I in the denominator. So that was our goal. Now there is a common factor here. So I'm going to go ahead and put this inside of a heart. And I'm going to divide by 2. Alright, all of these are divisible by 2. So that's going to give me 15 minus 3i over 13. So this would be an acceptable answer for number 9. Okay, looking at number 10. Again, we have a binomial in the denominator. So when you have a binomial, you multiply by the conjugate. So we keep the real term the same, but we do the opposite of the imaginary term. So I'm going to do plus 3i. This is the conjugate. So I have to do the same thing in the numerator though. Alright, it's all based on the denominator. So I'm going to have to double distribute in both of these cases. So let's get ready. So in the numerator, I'm going to multiply by 3, negative 3. So that's going to give me 18 minus 9i. Okay, and then I need to multiply by negative 3i. So that's going to give me plus 18i, and then minus 9i squared. Okay, now I'm going to do the same thing in the denominator, first multiplying everything by negative 6. So that'll give me 36 minus 18i. And then I need to multiply by 3i. I'm sorry, negative 3i. So that's going to give me positive 18i. That's a little too low. A little too low for me to just move on. So that's going to give me positive 18i, and then minus 9i squared. Now remembering that I squared is negative 1. Okay, because I squared is negative 1, that's going to change this minus 9 to a plus 9. And again, in the denominator, this minus 9i squared is going to become plus 9. Now I'm just going to bring down everything else. So I have 18 minus 9i plus 18i. As I do the denominator, I might as well go ahead and cancel these out, and I will just bring down that 36 right there. Alright, so now I'll bring the rest of my work up over here. So combining like terms. Okay, yeah, I'm down here. So combining like terms, I have 18 plus 9 is going to be 27. So I'm going to have 27. And negative 9i plus 18i is going to be positive 9i. So 27 plus 9i. Okay, over 45. Now, all of these are divisible by 9. That is a common factor. So I'm going to go ahead and divide everything by 9. So that's going to give me 3 plus I over 5. So this would be an acceptable answer for number 10. For number 11, since we have a binomial in the denominator, we are going to multiply by the conjugate of the denominator. So this will be negative 5 minus I. And we'll have to do the same thing in the numerator. So negative 5 minus I. Alright, and so now we will double distribute. So I'm going to take this 4 and multiply it by each. So that's going to give me negative 20, and then minus 4i. And then now I'm going to multiply by 5i everything. So that's going to give me minus 25i minus 5i squared. I will do the same thing in the denominator. I must double distribute. So first multiply everything by negative 5. So that's going to give me, whoops, almost put negative something, but this is going to be positive 25, and then positive 5i. And then now I'm going to multiply it by I. So that's going to give me negative 5I minus I squared. Okay, so now what do I have? So I'm going to have negative 20. I'm just bringing all this down. Negative 20 minus 4I minus 25I. So this is the only thing that's going to change. I squared is negative 1. So this is negative 5 times negative 1 is positive 5. So this will change to a positive 5. And similarly in the denominator, I can bring down my 25. Now the positive 5I and negative 5I, they cancel out. Now what do I do with this minus I squared? Well, it might be helpful to just put a 1 in front of here. Normally we don't need the 1 because it is understood, but it helps many students to understand what's going to happen now. So what we have, because I squared is negative 1, then what we have is negative 1 times negative 1. So that is going to be a positive 1. So that's what we have. Alright, so now we'll bring the rest of my calculations up here. Combining like terms, I've got negative 20 plus 5, so that's going to be negative 15. Negative 4I minus 25I, that's minus 29I. Always put the imaginary term last. And this is all over 26. So there is no common factor, so this would be an acceptable answer for number 11. There are a few other acceptable answers. Okay, number 12. See this negative out front? Let's go ahead and take that negative and actually put it on the 4I. Okay, so that's up there now. Now, after that, I'm going to do what we've been doing this whole time. When you have a binomial, you multiply by the conjugate. Alright, so I'm going to do 3 plus 5I. That's the conjugate. And I have to do the exact same thing in the numerator. So 3 plus 5I again. Now in the numerator, this is simple because all I have to do is distribute the negative 4I. So I am going to get negative 12I minus 20I squared. Alright, in the denominator, I'm going to have to double distribute. So first distribute the 3. So that's going to give me 9 plus 15I. Now I will distribute the the negative 5I. So that's going to give me negative 15I minus 25I squared. Okay, now remembering that I squared is negative 1. Okay, so because I squared is negative 1, I have negative 20 times negative 1, that is positive 20. Now I'm going to go ahead and put that first, and then I will simply bring down my negative 12I. That's my numerator. In the denominator, I see I have this positive 15I and this negative 15I. They cancel out. So I have 9, and negative 25 times negative 1 is positive 25. Okay, so that is going to give me 20 minus 12I over 34. And these are all divisible by 2. That is the GCF. So when there is a common factor, you need to divide by that common factor. So I'm going to divide all three numbers by 2, and that's going to give me 10 minus 6I over 17. So that is an acceptable answer for number 12. Alright, just a couple more problems here. I see that again we have a binomial in the denominator. Whenever that happens, you multiply by the conjugate. You keep the real part the same, and you take the opposite of the imaginary part. And then you do the same thing in the numerator. -1 plus 3i. Okay, so we have a binomial times a binomial, so that means we will have to double distribute to do this. So first I will distribute the -1. So that will give me +1 minus 3i. Next I will distribute the -6i. So that will give me +6i minus 18i squared. Now in the denominator, first I will distribute the -1. So that will give me +1 minus 3i. Now I will distribute the -3i. So that will give me +3i minus 9i squared. So I'm just going to bring down these first three terms. So I have 1 minus 3i plus 6i. But I squared is -1. -18 times -1 is +18. I'm going to bring down these three terms. Well, psych, these will cancel out because they're opposites. So I'm just going to bring down the 1. And I squared is -1. -9 times -1 is +9. So now I will have I have 18 plus 1, so that will be 19. And -3i plus 6i is going to be plus 3i. Only, you know what? I should write that. No, that's the way you write that. Anyway, in the denominator I have 10. And there is no common factor, so this is an acceptable form of the answer for number 13. Let's do one more. Another binomial. So once again, when you have a binomial in the denominator, you need to multiply by the conjugate. Keep the real part the same, do the opposite of the imaginary part, and then go ahead and multiply the numerator by the exact same thing. Okay, I will have to double distribute. So that is going to give me 10 plus 8i. Alright, now I have to distribute the I. So that is going to give me 5i plus 4i squared. Now I must double distribute in the denominator. That's going to give me 25 plus 20i. Now I must distribute the -4i. So that'll give me -20i minus 16i squared. So I'm going to copy down these first three terms. So I have 10 plus 8i plus 5i. But the last term, I squared is -1. 4 times -1 is -4. In the denominator, these are going to cancel out. So I'm going to bring down the 25. I squared is -1. -16 times -1 is +16. Combining like terms, 10 and -4 make 6. So I'll have 6, and then 8i plus 5i is 13i. And in the denominator, that's going to be 41. And there is no common factor, so this will be an acceptable answer for number 14. That's the end of this video. I hope it was helpful. I will see you on the next video if you want to know how to find the absolute value of a complex number.